Welcome back. In this video, we're gonna continue working on resources, but now we're going to get the resources mutably so we can update them if necessary, and then everywhere else, we'll get the updated resources. So let's first start in our integration tests here. We have our resources. We're gonna add a new one. So new test function. This is gonna be get resources mutably. So we're gonna start with, let's see, we need to create a new world. So let new world equals world new. We're gonna need to add a resource. So just pretty much exactly like this. We can even just add in this FPS resource exactly the way we have it. And then we're gonna have to get this resource, but get it mutably. So what is that gonna look like? We're probably gonna do something like let FPS equals world dot get resource mute. And at the type, so this is going to be the FPS resource. We can unwrap it because there's some possibility it will return a none. Once we get to this point, okay, so we have our FPS. We would assume that this should be a mutable reference to an FPS resource. Now, if we want to make a change to that, we can now make any changes we need. So we can say FPS dot 0. Let's like add plus equals 1. Then we should be able to do another query for this, and then we should be fine. So let's say we put this into a block, so that way it will auto drop at the end. So we can almost imagine that this is its own function somewhere doing something, where we have like a system that updates the FPS. And then we have a completely different system here that's going to do another query once again. So basically we're going to now get resource. Okay, so let our FPS equal to world dot just get resource. We're going to pass it in FPS resource. We're going to unwrap this. Okay, so we should get that back, and now we can do an assert equal. So assert equal. So in this case, it would be our FPS 0.0 should now be 61. All right, so I think that's good for our test here. So you'll notice that I created this block. The reason why I created this block here is because in Rust, variables are block scoped, meaning that at the end of the block, they're going to be dropped. So this FPS that we create right here, because it's inside of this block, it's not going to be the same FPS here. So we're not just shadowing. The entire, like the memory location is cleared out. It's dropped. So that allows me to basically get this mutably here and not be also getting it immutably here. That's now I could also like implement, like just do a drop manually itself. This could go into a function, but we're really trying to simulate that two different systems happening here. So I think this is fine. All right, so we're beginning with our getting resource mute is doesn't exist yet. So we kind of need to do that. Let's go and build that. So in our main library, we need this get resource mute. Now, we also know that it's going to take a T, which takes this any, just like the other one. In this case, we're going to have to get a mutable reference to self. Otherwise, it's not going to, return the right thing. And we're also going to return the correct thing here, which is an option with a mutable reference to T. Now, we don't have anything to return in yet, so I'm just going to return a none, which will make this not unhappy with me. So nothing is yelling at me. However, if we run these tests, we should get a failure because we're not getting the right type. Yeah, called an unwrap on a none value, which is exactly what we were expecting here because, hey, we're unwrapping and we passed in a none. Okay, that's fine. But this allows us to come back into here and figure out what exactly we need to do to support this. Let's go into resources and we're going to write a test here to help us out with that. So this is going to be get resource mute let's see, get resource mute. We're going to initialize the resource. That should be exactly the same. Now, if we remember, initializing the resources just happens right down here. It's our helper function. It's going to create a world width resource here and add that in. Okay, so we should be able to mutably get that out and then mutate that. So we want to be able to something like a get mute probably. So let world width equals resources. So this is going to have to be mutable here. Get mute. And we're going to have to pass in the type as well. So in this case, it's this world width. And let's unwrap this. So in this case, you should, after we unwrap this, then you should be a mutable reference to a world width. Okay. Now you're going to yell at us because we're not there yet. So let's go ahead and start creating this. Let's see. And in fact, at this point, we could do the exact same test that we have elsewhere too, right? We can now do a world width .0. This gives us access to that. Plus equals to 1.0. Then let's we need to put this into a block. And then we're going to do the exact same thing again. Except now we can get it immutably. So let's see, that world width equal to resources dot get ref width unwrap you. That gives us this reference to world width. We can now do an assert equal to world width dot 0 should be now 100 101.0. All right, let's make everything compile and then we'll make it all pass. So get mute. Okay, so get mute. We also take a T that must implement any. We're going to take a mutable reference to self, and we're going to turn an option with a mutable reference to T inside. We need to get that type ID, so we're going to do the same thing that we do up here. So type ID is equal to the type ID of T. And then we're going to do that exact same downcast ref here. So that should be fine too. So if let sum, and get the data, self.data.get. In this case, we're going to do a get mute, and then also a reference to our key, which is this type ID. Okay, so we know that if it's not this thing, we're going to return a none. But if it is, we need to downcast that and return the result of that. So we're just going to do data.downcast mute. And that should be it. Okay, so now it's just yelling at us that we're not implementing get mute. We're not implementing it because no one else in the main library runs it. So the main function, the main world is going to eventually, but we can run this test first now. So let's run you, and it passes. Okay, perfect. And now if we come back to these resources, so our integration tests, we should be able to run this, and it fails because we're still unwrapping on a none value. So what we need to do is come back into here and now use that function we just wrote. So we're going to do self.resources.getMute and pass it in this T. And then just pass on through the result. And then cannot forget the 2 colons. All right, let's try this again. So here we are. Run these tests. Oh, everything seems to be working. Let's go ahead and just run all tests and make sure that everything is working everywhere. And it is. Okay, perfect. So then, is there anything we need to clean up for this feature? In our integration tests, we have no warning, so I don't need to worry about that. In our integration test, we're doing a lot of very similar things. Like we're adding this resource, we're creating a new world. This is the only really difference part here. Now it's only 2 lines, but I would assume that for delete, it's going to be the same thing. Let's do the exact same thing we did before and create a helper function in here. So we have a helper struct essentially. I create a function, initialize world. We're not going to take anything in, and we're going to return a new world. So what are we going to do? We're going to do this essentially here, and then we're going to return world, which means that at this point, we can now just run initialize world. And we do need to assign this to let world equals. And in this case, we don't need mutable access to it. And in this case, we do. It doesn't save too many lines, but what it does mean is that if I ever need to add more resources in or do anything else with other tests, there's just one place for that to change, and everywhere else gets that change, and I don't need to worry about anything going weird with that. Okay, so that's good there. We can close this file down. Let's see, in our main library, I don't necessarily think there's anything in here that we really want to add in. Now, something I didn't add in before, but I think we're going to do at the very end after all of the implementation stuff, is add some documentation for our users for how to use this stuff. So what we can do here is I'll add in the resource mute one because we just did that, and that's part of this video. So if we do these triple slashes here, these are the doc comments. These are actually going to be visible in the documentation. And we'll build that documentation and we'll actually be able to see that showing up here. So this is query for a resource, get a mutable reference to it as a mutable reference to it. There's like not terribly too much we need to like add into here. Takes a type. Let's see, since we're storing the types as the type ID for the key, so the type of the source must be added, must be added in so that we can find it. Now we can also do example code in here. So if this is just markdown, so if we add those triple, the triple backticks for like there's a code example, we can actually set things up in here. Now to write the actual markdown test, we can't just call this code by itself, you know, here. What we have to do is we have to do a let. We have to actually bring in. So we're going to do use and then the entire project name here. So our project name, if we go to cargo.toml, is this. Not exactly a short name. And then we can bring in, I believe it's just world. And then we can start using it. So now we can do let our world equals world new. We can insert anything that we want. So we can use like an I32, for example, in this case. So we do world dot source. Let's just put in like a 10 E32 as our type here. And then we should be able to get the resource mutably here at this point in time. So we're going to do this in a block. Okay, so I somehow, oh, it lost this. Okay. There, I was wondering what was going on with that, the color highlighting there. And apparently when I auto opened a block, it didn't keep the triple lines in here. Now this is kind of like annoying. I'm having to like redo that over time. If I'm just anywhere in here, I can do a control dot. I'm on Windows, so that might be a command dot. I don't know. And Rust Analyzer will switch this over to this style comment, which now I don't need to do. I don't need to like manually add in those slashes anymore, and I'll switch these back afterwards. Okay, so we want to do world add research. Okay, so we need to now mutably get that. So we're going to do let whatever this data is. So this is our resource equals world dot get resource mute. In this case, it's a U32. We're gonna unwrap this. And then we're going to mutate it. So source, we need to dereference this so we have access to the location in memory, and then we can plus equals to 1. And then down here, we should be able to get that resource again. So that's going to be a let source equals world dot get source to wrap it, and then we should be able to assert equal. So assert equal that in this case our resource, so a dereferenced resource, is equal to 11 now. So what I'm going to do is I'm going to run this doc test. It passed. And then if I want to actually see this, this documentation here, we can do a cargo doc. It compiled this, and I need to do a cargo doc -- open, and it will open the documentation in a browser. So I move this over here. We can now see, here's the world. Here's this new documentation that I just created. And this example code is guaranteed to be working because in Rust, when I compile, it also runs all of the doc tests. So if you do want to have documentation, then this is a great way to add it into the project. All right, with that, delete is going to be next. So I'll see you in that video. Bye.